Today I'll be explaining how we can create a counter using D flip-flops. So our objective is to create a binary counter that counts from 1 to 2 to 3 and repeats this sequence of numbers. And we could also make it, we can make it count in the opposite direction, where we can have it start at 3 and then count to 2 to 1 and loop in that sequence. As you can see in the illustration I've shown here, our 0, our special case, will either point to 1 if we're going from 1 to 2 to 3, or it'll point at 3 when we go 3 to 2 to 1. This is just something to note when we go ahead and make the excitation table. So firstly, what we're going to do is we're going to determine the number of D flip-flops. So this is fairly simple. All we have to do is just go ahead and look at the number of bits we're dealing with. And as we can see here, we're only dealing with a maximum of 2 bits at any given time. So that means that we're only going to be creating 2 D flip-flops total, which means we'll have 2 variables that we need to account for. So as you can see here, I go ahead and make the counter that goes from 1 to 2 to 3 and loops that sequence, and the counter that loops from 3 to 2 to 1 and makes that sequence. Now, the way we would do this is through a utilization of a direction bit. As you can see here in this orange column right here, you can see that we have a 1 marked in each spot. We're going to have a direction bit of 1 each time for this sequence here when we go counting from 1 to 2 to 3. And we're going to have a direction bit of 0 from when we count from 3 to 2 to 1. As you can see here, I have my A and B and the next states here marked with the plus. So if we're starting at a 0, we want to go to a 1. And if we were at a 1, we want to go to a 2. And if we're at a 2, we want to go to a 3. And then if we're at a 3, we want to go back to 1. And then when we're doing the counter that counts from 3 to 2 to 1, we want to have, if we have a 0, it goes to a 3. If we have a 1, it goes to a 3. If we have a 2, it goes to a 1. And if we have a 3, it goes to a 2. Now when we're creating the D flip-flop for A and B, all we need to do is, it's very simple. We just copy over our next state for A and our next state for B verbatim. So we look at A plus, this entire column will be our D flip-flop for A, and we look at B plus, this entire column will be our D flip-flop for B. Now what we do is that once we create the excitation table, we can go ahead and use that to create our K-maps. So the K-map for A, as we just go ahead and fill it out like a regular table. So we look at our up-down, our direction bit here. We look at 0, 0, 1. We look over to 0, 0, 1, fill in our 0 here as marked in our D flip-flop table for A, and we just go through and we align all of these A, B, and direction bit values with the values in our D flip-flop column here for A. So we just go through and fill this all out, and when we're done filling this out, we can see that we can group these two ones here, which have the commonality in these two columns are not A, and it's in the not UDN row. So this will give us a not A, not UDN. And then our next thing we can group here is not AB. It's just in this column here, and there's no commonality in the rows, so this will just be not AB. And then we also have a B over here that is in the commonality between these two columns, and it's in the UDN not row. So we're going to have this as B not UDN. And then finally we have one more here, that just this lone one that we cannot group with anything, so it'll just be exactly where it is positioned in the K-map, so it'll just be A not B and then UDN. And we put an OR signal in between all 4 of these possible equations. Creating the K-map for B is the exact same way. All we need to do is we just need to group these 4 ones by crossing over the K-map, and that'll give us not B as the only commonality between those 4. And then what we need to do is we need to group these 2 ones here, and the commonality between these 2 columns is not A, and then it's in the UDN not row. So that'll give us not A, not UDN, and then we go over here, and we see we have another commonality in these 2 ones here. We get an A, and then it's in the UDN column, or the UDN row, rather. So then we get A, UDN. And then finally, what we can do is we use these equations to create our circuit, which I'll go ahead and show over here. As you can see, we have our direction bit set to 1 in this switch indicated here. So what we could do is if we flip this switch, it'll start the clock, and we'll count from 1 to 2 to 3, and it'll loop this sequence. And then if we go ahead here, and just do it one more time, now we go ahead here and we flip. I just turned off the clock. Now if I do the direction bit to 0 and I reset this, we can see that it'll start counting backwards from 3 to 2 to 1, and it'll loop this sequence. And as you can see here, I've just created all of my equations, and I've hooked them all up to their respective D inputs in each flip-flop. And that is how you can create a binary counter using D flip-flops to count from either 1 to 2 to 3 or from 3 to 2 to 1 utilizing the direction bit. Thank you very much.